Capella is the brightest star in the northern constellation of Aurigae, the sixth brightest star in the night sky, and the third brightest in the northern hemisphere, after Arcturus and Vega. Hi everyone, Vega here, and in today's video we're going to start what is potentially a new subset of our Brightest Stars series, where we look at some famous stars to wonder and speculate what they might have been in their younger years. So let's get to it. We've looked at the major stars over these last few years, the ones that many people know of, and indeed some cases we've looked at those very stars' futures. But what about their past? What were these stars like when they were young? Capella is a giant star, very easy to find in the night sky and a prominent member of the winter hexagon. It's also relatively close at 42.9 light years from the Sun. Indeed, curiously, it's one of the brightest X-ray sources in the sky, and it's thought to come from the corona of Capella AA, the largest star in the system. If you look through endless lists of nearest stars like me, it becomes quite apparent just how rare giant stars are. Swathes after swathes of red dwarfs as far as the page is long, many K-type dwarfs and indeed brown ones. In fact, you even realise just how rare sun-like stars are really, but giant stars are another level of rareness down the list. Although it appears to be a single star to the naked eye, Capella is actually a quadruple star system organised in two binary pairs, made up of the stars of Capella AA and Capella AB, Capella H and Capella L. The primary pair, AA and AB, are two bright yellow giant stars, both of which are around 2.5 times as massive as our Sun. The secondary pair, Capella H and L, are around 10,000 astronomical units from the first, and are two faint, small and relatively cool red dwarfs. Capella AA and AB exhausted their core hydrogen and cooled and expanded, moving off the main sequence. They're in a very tight circular orbit, about 0.74 astronomical units apart, and they orbit each other every 104 days. The most luminous Capella AA is the cooler of the two, with a spectral class G83, and is around 78 times the Sun's luminosity and 11.98 times its radius. An aging red clump star, its past fusing hydrogen is interesting now fusing helium to carbon and indeed oxygen in its core. AB is slightly smaller and hotter and has a spectral class of G03. It is around 73 times as luminous as the Sun and 8.83 times its radius. Currently finding itself in the Hertzsprung gap, it corresponds to a brief subgiant evolutionary phase as it expands and cools to become a red giant. The traditional name Capella is Latin for a small female goat, and technically the catalogue of star names lists Capella as applying to their star Alpha Aurigae AA. Besides its own parameters though, Capella has also quite an interesting history as it was the brightest star in the night sky from 210,000 years ago to 160,000 years ago, and reached a dazzling minus 0.8 in apparent magnitude, brighter than the star of Canopus is today. Aldebaran was brightest before this period, and interestingly, it and Capella were also at the time situated rather close to each other in the sky, and approximated the pole stars at the time, which as you might appreciate must have made quite a spectacle, with both Capella and Aldebaran shining so brightly and closely together, and right at the top of the sky. Indeed, the closest approach to our solar system of the Capella stars was around 240,000 years ago, when the stars were just 27.9 light years away, which is quite incredible really, having such huge stars so relatively close to our system. Aldebaran, for its part, actually came even closer at some 21.5 light years at very closest approach. Both systems of course have now dissipated away from us to a degree, and Capella will continue to fade away, travelling now at some 31.63 km per second away from us. In more recent history, the first time Capella was announced as a binary star was when Professor William Wallace Campbell noted on photographic plates taken in August 1896 that a second spectrum had appeared superimposed over the first, and indeed there was a Doppler shift to violet in September and October, and later to red in November and February. This showed that both the components were moving toward and away from the Earth, and hence orbiting each other. Later in 1914, Finnish astronomer Ragnar Furuhjelm observed that the spectroscopic binary had a faint companion star, which as its proper motion was similar to that of the spectroscopic binary, was probably physically bound to it. And fast forward to 1936, when Carl L. Stearns observed that this companion probably was double itself, and indeed was confirmed by Gerard Kuiper. That pair of course are now designated Capella H and L. So Capella, the multiplicity system, has an interesting past, but what kind of stars were the main pairing before? Or in other words, what were their progenitor stars like? Well, having scoured the internet, there really isn't much information, but assuming the smaller stars have always been red dwarfs, and presumably will continue to be so in the long-term future, we can reason that if we take the two more massive stars, AA and AB's masses 2.56 and 2.48 solar masses respectively, and make a tentative assumption that at their current stage of evolution, they haven't lost much mass as of yet, which tends to be the case as stars swell into red giants. So we could compare those masses to stars at the very top end of the A-class main sequence, or in other words, A05 stars, a bit like Sirius or Vega, as we see in this table, but even further probably pushing to the limits of the B-class, and much like the star of Alphecca or Alpha Corainae Borealis, which has a mass of 2.58 suns and an A0 designation. Alternatively, one of either both stars could have breached that boundary, become a bit bluer in colour, and found themselves unsurprisingly right at the bottom of the B type of category, similar but less massive than Algol the Demon Star or Beta Persei AA1, which has 3.17 solar masses, or indeed the famous star of Regulus, Alpha Leonis A, although Regulus, the Harry Potter star, is quite a bit more massive. For reference, the lowest realistic mass for a B95 star would be around 2.1 solar masses, and the upper limit for an A05 star would be around 1.9 solar masses, technically, so more likely the stars would probably be B-type than A-type, but it's certainly fun to speculate, isn't it? A typical B9 star would likely live around 500 million years, to at the very most 1 billion years on the main sequence, which seems roughly how long both Capella stars would have been there. We must remember that the stars are incredibly similar to each other, so what applies to one pretty much applies to the other Capella star too, although it would have been quite a curious twist of fate if one actually had been an A05 top of the A-class star and the other a B95 or bottom of the B-class. The stars will now spend around 100 million years in and around their red clump and Hertzsprung-Russell gap, and then possibly 100 to several hundreds of millions of years when they finally have finished their expansion in the red giant phase. Capella is a star system that once upon a time came very close to us, and for a relatively brief period shared the top of the sky with Aldebaran and shone as the brightest star in the night sky. Two large yellow giants and two tiny red dwarfs, the progenitor stars of the yellow giants were likely bridging the gap between the A and B classes, and indeed were like that for at least 500 million years. The two stars are now expanding, and as they begin their journey away from the solar system and back into the depths of our galaxy, they will continue to expand until finally, together, like two sisters, they reach their red giant destinies. Thanks for watching, and consider subscribing if you haven't already. If you'd like to support the channel further, you could consider joining the channel, or alternatively buy me a coffee, and I'll link this in the description. Many thanks to those of you who have already done so. Take good care of yourselves, look after your friends and family well, and I'll see you on the next one.